Hello. So migrating from a monolithic solution to an event-driven architecture can be a daunting task. It's a journey that more and more organizations are embarking on to enable greater agility, scalability, and innovation. So today I want to share some practical insights from a real customer journey that you might be able to apply to your own migrations. So the starting point for this is a gaming company, and they were running this monolithic .NET framework application running on a Windows server or multiple Windows servers. And the database for that was just a large SQL Server database. So probably quite standard for a lot of people here who have seen a kind of monolithic app. The specific bit of functionality that I'm going to kind of walk through, because obviously there's a lot to tackle in there, is when a new customer registers against this website, which the monolith is running, then automated checks need to be made using a third-party API to check that they are over 18, and then they can deposit money and they can play the games. The result of that will then be stored in its large database. And then throughout that system, when they go to try and deposit funds, to go and try to play games, then it's doing all these checks against the database in lots of places, even from within stored procedures, from triggers and so on. If a negative result comes back from that, then their account is locked and they can't play and they have to contact customer service. So the goal with this was to try and break it down into different domain-based services. So we wanted to end up with something more like this, more microservice-based, using events and trying to break down into the different bounded context, basically. So each service would either be its own bounded context or there'd be a set of them. But the important thing is just trying to extract that behavior. So the coupling should be a lot looser than the monolith, because the monolith wasn't, you can have a good monolith in theory, but it was very coupled. Obviously, it was a very legacy application. So I changed to, say, the age-related functionality. Maybe we're hitting a third party, you hit a different third party, then that would be limited to that single self-contained service. I'm Martyn Kilbryde. I was here last year, so some of you might remember me from there. I'm an AWS ambassador, community builder, and I am a principal solution architect at D55, who are in Manchester. So we first started with this age verification service. Now, the only communication with the rest of the business was initially via events. So you'd have an event coming in to kind of trigger the verification checks against the third party. We would store them results along with like an audit history in its own database. And then the output of that, whether they were verified or not, would get output as an event. So quite a standard microservice premise. I'd like to walk through how we sort of moved across using different patterns, how to do the integration and the migration. Now the first pattern is probably one that everyone would expect me to say, which is Strangler Fig. If you're not familiar with it, it's coined by Martin Fowler about 20 years ago and named after the plant which strangles a tree over a year and kills the host tree and replaces it. So the metaphor has stuck around to represent this process of having this monolithic application and gradually taking behavior out, and that monolith kind of gets smaller. And over the years, you end up with a point, depending how long it takes, years is probably more likely if it's a large monolith, that'll become redundant. So we started with that registration age checking process that I mentioned. That was the first bit we thought we'd tackle. And then once that feature was extracted, then we moved on to another piece of functionality, say deposits, and extracted that, and so on. Now the second is just the event pattern that we used. So there is lots of different event patterns you can use. So we used the event notification for this. So in that monolithic application, we had a user registered event, for example. Now the event notification pattern simply just sends an event when there's a change in its domain. So the important part is that it doesn't care about what's consuming it. Effectively, it's just throwing that over that wall, and it's consumed by something, it doesn't matter. It's just a broadcast. This is different to maybe other patterns like event sourcing, which is a change event as well. but the idea of event sourcing is that every change is published, and then that event log can be used to rebuild a system. Now, the next pattern I'd like to go on to is dark launching. So with dark launching, we have our monolithic legacy system. Somebody will register against that. Now, the idea is to keep the legacy code running. We don't want to change that. We want to try and get our new service in place. There's a lot of risk with just trying to swap out that behavior. It's been around for a while, this legacy application. So we just want to assess that new feature. So at this point, we can fire the event from that system. So the user registers, and that'll go through the event bus and hit our new service. But that monolithic legacy code continues on, does the third-party check, stores it in the database, and just carries on as normal. The age verification service, the new service, we actually released it, so initially it just received the event and did nothing. Over time, continuous deployment, it was starting to hit the third party, store the results in its database. And there came a point in time where it was basically doing all of the functionality, and at the end, that event is just either not being fired, or in this case, it was just not routed to the destination from EventBridge. So at this point, we've got two databases. We've got our new database, which is in the age verification service, which was actually DynamoDB, and the old database, and we can take a portion of time and check that they're in sync. We can do deployments and break the application by accident, looking at logging, observability, making sure it can handle the actual load of the live system. It's basically live testing at this point. Now for this dark launching to work, it then kind of goes into the next pattern, which was feature toggles, sometimes called feature flags or switches. Now they come in different flavors, but in this, I'm kind of talking about release flags at this point, which are typically used for kind of like trunk-based deployment, continuous delivery, and so on. So the idea being that, that feature gets added behind this, basically a Boolean check. And then ideally, that's just changed in config and again, remotely if possible. So it's not a release. And that'll just switch to the new feature. So with this in place, you can release that code rapidly to production. They're just not executing your new changes. And it saves having these big, long release cycles. And then it can be tested in the staging environment where it's switched on and go to production, and then we can make that switch. So just looking at very basic pseudocode of this registration flow. Somebody registers, we're going to save them to the database. We also need to do this third-party call. We need to check whether they're verified or not and persist that into the database. So the changes to the monolith were just needed to be around this point was to put the feature flag around the behavior to do this third-party check, but to do a negative around there because we've not enabled the new service yet. And then also send this new event notification. Now at this point, we can release the new system, and this event's been fired. We can do all the testing that I spoke about previously. When that flag is enabled remotely, because we're using it's not a local configuration, it means that it can turn on the event being kind of either sent from the service or being routed, and disable this behavior at the exact same time. So it allows us to get to that point, and we can flip back again if we need to. Now the final pattern I'd like to go through is like legacy mimic. So the idea of a legacy mimic is to fill a gap where the existing system has a contract of some sort, and the new system has to continue to fulfill that contract, which for a legacy system, which is so dependent on that database, so dependent on how it's been built, is actually really important to do. So for this project, there was this kind of monolithic database. There's lots of Boolean checks. Are they age verified? It happened all over the place every time you try and play and deposit and so on. So it's important to continue persisting that into that database, because the alternative would be to change all of them areas to do, say, HTTP calls into the new service to check the state. And that might not even be possible because, like I said before, you've got stored procedures, you've got triggers. So by doing it this way, you've just got that, you don't need to change anything other than the saving into the database. You don't have to go through that code base, which could be quite painful. So just to walk through that a little bit, we're submitting our registration event to our new service. At this point, just to kind of, from a legacy mimic point of view, we just need to persist that result in the existing database, right into there that they're verified true or false, and the rest of the code will continue to work. But to avoid the new service from having to touch the legacy database, because we don't want 15, 20, 100 microservices all talking to that one legacy database, this is where we can create this legacy mimic service or a contract service of sorts. And its only job is to listen to events and push that data into the database. So it's listening to the whether they're verified or not, that result coming from the age verification service, and it knows exactly how to persist that in that monolithic database to keep that contract. And eventually that service is decommissioned. Its only job is just to keep the monolith running. So just to put that all together, we've got our monolithic system at the top there in the database. Somebody registers against that system, we submit our event through our event bus, and that gets routed to our new service. The new service goes off, does its checks against the third party, persists it in its database, which is now the actual source of truth when this is enabled, and then submits its event out. EventBridge then can route that, instead of back to the monolith, for example, it can route that to our monolith contract, our legacy mimic, and at that point we can persist it in the database. So now the legacy system can just continue doing its age verification checks. Now, as soon as we got this out to production, there was other scenarios that come about. So it turns out you can change your date of birth because maybe you put your date of birth in wrong when you registered. And so they'll have to ring up and say, look, my account's locked. And the person would use their admin tool and would update their date of birth. So the only real change we had to make at this point was in the admin tool, which was also a kind of monolith, but PHP in this case. Submit an event from the system to the event bus and basically route that to the age verification service. That does the exact same job. It's basically just getting an event to say, you need to do a check, and here's a kind of customer ID, and give it some basic information. Now, at this point, the database technology for that age verification service was DynamoDB. That monolith, like I said before, with Microsoft SQL. The code for the monolith was .NET. That was written in Lambda, was a Node.js Lambda. So it's a completely different dev team. I was a consultant on this. I wasn't in the main dev team. It was a completely different language, completely different technology. It allowed them to move basically to serverless from this monolith. Now, the other benefit with this is when it came to dev and staging, it might be that third-party system. They had a staging environment, but they didn't have a development environment. We want to do integration testing to test this. You want test automation as much as possible so we can do continuous deployment. So this service at the bottom, where we're doing this third-party check, well, we created our own mock using API Gateway mock and just swapped out through configuration. So that age verification service in the development environment would be hitting a fake endpoint, and then we could stub it for certain users would be underage and so on. And also in production, we could also make that change, and obviously the monolith doesn't care at this point. So it sounds good, but what about the problems with this? First is latency, and there's been a couple of talks that have mentioned this today. Monoliths might be a problem to work with. Developers generally kind of hate working with them. But by processing everything synchronously in the same process, they can actually be pretty quick. And by swapping to an asynchronous processing system, and with all the different layers, so event bus and the different microservices, then it's going to take longer to get that result in general. But that new architecture should be more scalable and resilient and so on, so there are more other benefits. So if we just walk through a little example just to show this, that person registers and we get our events into the event bus, and like I said before, it's going to send that to the age verification service. And that'll just publish its result. But at this point, that user might go to the website and try and deposit money. So the monolith will go to the database, and there's no failure there saying that they failed the check. So either they're going to get an error, or they're going to be allowed to deposit money, where it's not got the result it needs. At this point, the event might eventually get to the Monolith contract. Depending on the latency, it might be retries and so on. There might have been network latency there, we don't know. It'll store it in the database. It's too late at this point. Now, the fix for this is obviously very dependent on the use case, which is a very developer way of saying it depends. But for this specific scenario, you can imagine it's a Boolean check that they're verified or not. So if you default that to false, you've kind of mitigated the problem a little bit. You've defaulted by it to false. Nobody's age verified until they are. So nobody can deposit until you've proven that they're of age. So this is the safest way for the business, but it can be quite jarring for the customer. And they don't know why it says you're not verified, but they say I am verified and so on. But if you default it to true, the customer's really happy. But obviously, depending on this is, say, regulatory, that could be bad. So, again, depends on the use case exactly what will work. The third option is to default it to null, be a blank row or so on. And at this point, depending on the monolith, you might be able to make changes to, say, deposit, depending on how that works, so that if it is null, it can show a message saying that the person, you're not yet verified. And that's the option we took in this. There's a few different patterns we had to do, but effectively, if you've not got the result yet, a true or false, then we don't default to anything. We show a message and say, sorry, try again in a minute. The second, which is related to latency, is race conditions. Again, you're asynchronous now, so you're going to get out of order events, you're going to get delayed events, you're going to get overlaps, you're going to get the problems that come with latency and just being asynchronous. So let's say they register and it hits the event bus. But in this scenario, we've now got another service. So that registration event gets sent to two services. So we've got our age verification service, but we've also got a new customer special offer service. Its job is to give new customers an offer of some sort. It wants the registration event for persistent into its local database. We're a microservice, we want some basic customer information stored in our database so we can assign a special offer later on. The age verification result comes in, that says they're verified, that gets routed into the offer service. So the offer service now knows they're verified and goes, okay, this person's over 18, I'll read them from the database, assign them an offer. But if there is some latency in this, if there's a communication error, for example, and that event does not get through at the start, it might just be a underlying issue there, but it could be just a network issue and it's going to get retried in 2 seconds. At this point, the age verification service now is its result has come in, hits that database, there's no customer to read. So it'll either fail or not assign a offer. And then eventually we will get that registration event, but again, it's too late. Now, because if these events aren't orchestrated, then this is going to happen. It's just something you have to work around, you have to deal with, and have to have procedures in place for, and you have to make sure you test this scenario when you're building in dev and so on. So again, it depends, but if we will look at the type of the event bus. So if it's a queue, pub sub, first in, first out, and so on. If it's first in, first out, then you've got that guaranteed ordering, and it might reduce that problem a little bit, but it sacrifices other aspects. You've got performance, scalability potential issues. You've got the impact of, say, a poison pill message, which might block that kind of queue. The other is just the error handling and retry capabilities of that type of event bus. So if it does a fire and forget to the service, like an SNS, then that service and the service fails, then who knows it's failed, that event's lost. If it's a queue, then we can process it and we can delete it from the queue when it's successfully processed. So it'll get retried and doesn't get lost. If it is a fire and forget, there is the other option of holding onto it. So you get the events saying, please, these are age verified. You go to your database, they're not there. You could hold on to that. You could have an internal queue. You could build in some functionality to try and deal with that scenario, but that's probably making you all shudder because that would be very difficult to kind of test. It's a lot of complication that you're putting in there. The other option is that it's just accepted from the business that the offer doesn't get assigned in some cases. In general, it's always best to check if it's fine to do nothing before doing something, and there's an exceptional case. Like if it's going to happen 1 in a million times, then it's probably best just to let it error. If the customer's got a problem with that, they will ring up. Maybe you'll have a report and you can contact the customer manually. If it happens 1 in 100 times though, then you should be building something in to test that. The final option is to pull that data on demand. So as I said before, this registration event comes in to this offer service and it's storing the customer in its local database. That means it's a microservice in the kind of pure sense of the word, but it also means you've got customer data in all the services. In fact, for that, we had to create an event to be able to delete a customer, which gets sent out to all the services so they can all delete the user in case the user wants their data deleting. Which again, you've got the problems of data getting out of sync and so on. So if you don't store that current information, you can do a read call. So maybe you have a customer data service which has that data, that's the source of truth. But at this point, you do have a bit more coupling in place. You've got this direct coupling and the scalability of that is potentially now an issue because you're doing a synchronous call. Now the options could also be combined. It might be that if you have the data in the database, great. If you don't, then you go and pull it. Scalability is less of an issue. But now you've built in all this extra functionality, you need to test that. So you have to test that with automation and make sure you're continuously testing the fact that you've got this whole scenario that you've spent days building that only ever gets executed maybe 1 in 100 times. So moving on to another problem is around idempotency, which I tried to memorize exactly the definition for this, but it's awful. So it refers to the property of an operation where repeating it with the same input has no additional effect beyond the initial operation, which is very hard to understand if you've not worked with it before, and it's also a very hard word to say. So if we look at an example, say we've got the offer service again, we get an event of some sort for customer 49, and we go to the database and assign them an offer. That event comes through again. This can happen. Most of these services, like EventBridge and stuff, it's at least once delivery. That could error. We're trying to assign a row in that table. It's already a row. It errors. Maybe it gives them 2 offers, and now they start stacking offers. The idempotency is crucial to making sure that they're not processed multiple times. That's as simple as you can kind of put that. The retry mechanisms of all of these events, event buses, so EventBridge and SQS and so on, you've got even the asynchronous Lambda, you've got retries. You're going to get repeated events in production. It's going to happen. Again, testing that in your dev environments, trying to use automation and making sure you handle that is important. It's not just the customer pressed the button twice on the website. So there's a couple of ways to handle this. Idempotency IDs come into play here. So if you're using this metadata and you're passing these IDs, and it doesn't have to be a specific ID. It might just be the customer ID. It might be the customer's email address. It could be something that's unique for the use case. So in this case, we've got the offer. We need to assign an offer to a customer. So that could just be the customer ID. All it needs to do is check against some sort of a local table. So we've already processed this. And there are patterns for this. If you use Power Tools for AWS Lambda, they do have this kind of pattern, which will basically do that. It'll have a dynamo table, and it'll try to put in idempotency for you. The only things you need to consider if you are going down this route is if it gets hit at the same time or really close together, you might not have written into the idempotency table yet. So you're going to have race conditions kind of there. You might need to do lock-in. You might need to double check it multiple times and so on. Now, sometimes it might not matter. So, if you've got a new offer coming in, just check that there's not a new offer in the table before you write to the table. And that might be good enough. So rather than doing something specific with idempotency IDs and sticking them in there, just, you need to look at the full flow from a business point of view. Because it might be that it doesn't need to do anything in that service because the output of the service, like if we look at the age verification service, does it matter if we check their age 5 times in a row? It probably doesn't, because we'll get their event, we'll go to the third party, we'll output that they passed or failed. The downstream services that receive that event, they need to handle the idempotency. It's not my problem at that point. I'm only caring about doing what I'm told. Fundamentally, it comes down to how important it is to test for idempotency. Make sure your idempotency handling is working. It's not the easiest to test, but you can't rely on atomic transactional code if you're doing this kind of asynchronous process. Obviously, the other option is to use step functions and orchestrate it all, but I'm not going to get into that as an option at the moment. Next problem is just around the events themselves. So just having poor events, and by that I mean inconsistent naming. If you've worked with EDA, especially ones that have just grown and not been planned with event storming and so on, you've probably seen this quite a bit. User registered, registered user, that kind of thing. Duplicate events, again, you might have both of them. One service might submit one event with a slightly different name to another service, and they both end up getting used by multiple different consumers, and now you've got a problem because you need to try to merge them all together. You'll also end up with events that just have no purpose. So you're submitting events with the idea that they'll eventually be useful, but sometimes that'll just flood the system with stuff you'll never need, or it's not the right kind of event to fire. So it doesn't really ever going to have a purpose. And also you've got events with more than one responsibility, which can be a problem if you've got that user registered and you fire that out. That's just saying I registered, that's one responsibility. But if you end up pushing it all together, user registered and age verified events, then that's going to be quite painful. Now, there's Dave did a whole talk on this earlier about basically these issues. All I would say really as a solution for pretty much most of these is documentation. It's really important, especially when you're starting from scratch. If you can do it from scratch, from day one, get an event catalog there, whether it's this event catalog or another, it doesn't matter. It can just be a wiki. So one of the clients I've just started working with, sort of the first week sprint, we added in on dev an event catalog, IP restricted, it's there from day one. Now we can start to add in events to the system. But until we've got the documentation, I don't want to just start adding in events. By being clearly documented, you've got versions, attributes, you've got producers, you've got consumers potentially. It'll mean that all developers can refer back to that. You're not going to get duplicate events as long as you've got that documentation. And if you need to use an event, you can go in there, you can look it up, you can add yourself as a consumer, and so on. The final problem I'd like to touch on is the sort of 3 pillars of observability, so logs, metrics, and tracing. So when you've got this distributed architecture, they're basically even more essential for understanding that flow of events, understanding that if somebody registers and you've got a service that's like 15 services deep and failed, how can you track that? How can you find that? How do you know where that ultimately came from? So without having these in place, it can be like really difficult to find issues like slow message processing. What if you've got that third-party API is really slow? We now know that there's like 10 consumers of that, and all of them are going to be impacted. And you need to be able to find, oh, it's acting slow today, and what can we do about that? And also things like message duplication. You might be getting the same messages fired from a service. If you don't know that's happening, you'll just think, oh, I'm getting a load of traffic to the website today. But actually it's not. You're DDoSing yourself with message duplication because you've got a bug somewhere and it's retrying events and so on. A lot of this comes down to just not having that centralized logging and tracing. And also having the absence of performance or business metrics. And by that I mean, you get a lot of metrics from AWS. Looking at, say, Lambda, you'll get about 30 different metrics, but actually it's probably more important to have a metric user registered potentially, because if registrations drop, you've got a problem somewhere. Where if you find out that's Lambda's erroring, that tells you one thing, but it doesn't actually tell you much if everything seems to be working fine, but you've got a CSS error, which means somebody can't press a button. And also just the inability to correlate the events, which when we're talking about event-driven is very important. If we go from that flow of something where somebody's registering and it's going through all that system, eventually something's going to happen in a system really, really downstream. That's based on that event that came in. And you need this correlation all the way through so you can see, okay, exactly where this came from. There's lots of tools in this area. I'm not going to go into the tooling as part of this talk, but obviously think your X-rays, CloudWatch. There's obviously third-party tools out there that people use, like Datadog and so on. If you're using Lambda, you can be using things like the Power Tools to output metrics, for your business metrics. Get that dashboard, get your alarms in there, make sure you've got alerting, and first thing in the morning when you're getting your brew, look at that dashboard, see what's happened in the last 24 hours, look at maybe the strange peaks that didn't alert. You can see if things are going wrong pretty quickly when you do that. And similar to idempotency, it's important to test your observability. It's not just an add-on. Observability is a feature that you need to build. You need to think about. It should be its own task. The way I usually think about this is the 2 a.m. rule. I was on call for many years, so when you get that phone call at 2 a.m., if you log onto that system and you can't figure out what's gone on because of you or one of your colleagues not putting in a log which actually tells you what's going on, you'll be up till 6 a.m. You'll be up till, well, worst case was 16 hours, but you'll be up for a very long time, and it could have all been solved by one single log line. So it needs to be tested. You need to be looking at dev. You need to be looking at things like game days. You need to be breaking things on purpose. This is when chaos engineering comes into play. You can need to try to find these problems. You can drill to that issue really quickly. So in summary, when transitioning from a monolithic architecture to EDA, it's important to start small and gradually migrate. Don't do big bang. It'll never go well. Start firing them events sooner rather than later, but if you do that, just make sure you document them. Get that event in that the person's registered. Suddenly we could start writing a whole service behind the scenes for weeks and weeks and weeks, and nobody, from a customer point of view, knows it's happening. It's an asynchronous publish. But we could actually build this, test it in production, get it working, and then right at the end, just switch a feature flag. So using dark launches and feature flags just really, really helps when you've got, especially when you've got a legacy system which might not even have dev. It might be so complicated you don't really have a development environment. But also it's very hard to get load statistics and try and get the metrics so you can build load testing and stress testing. But if it's in production, you can just look at your observability and you can test that without impacting anything. Make sure you design for latency, design for race conditions, handle duplication, and just observe and improve that system over time. It's a journey. It's definitely not, oh, I'm done. It'll just keep evolving. The whole point of microservices, the whole point of event-driven is that you can basically delete that service, create a new service, swap things around, just keep on improving over time. Thank you.
All right. Guess we've got time for maybe one or two questions if anyone's got one. One right up the front here.
In terms of the event catalog, is that an automated process or is that something where your consumers are adding to the catalog?
Is Dave here? Guess not. So you can hook it up to EventBridge, for example. It's open source, so there's different ways to get events in there. So at the simplest level, it's a static website. You deploy it out from, you just document them and it gets deployed out from Git. So we actually put our event catalog in the same mono repo as our CDK code, which also had our Lambda code. And then every time the event's added or changed, it was one deployment. But you can link it to EventBridge and you can actually have it sucking events in basically from, schema discovery, basically. But yeah, Dave's around somewhere. He wrote it. So yeah, find him, ask him.
Cool. Any more questions? back here.
Thank you for the presentation. If within your event journey you realize that one of the consumers failed and basically the state hasn't changed for whatever reason, either network or something, and is there a way just to cancel this transaction, and how do you approach this kind of stuff?
Well, dead letter queues for the most part. It depends what you're using for your system. So if you've got, you need to, it's really important to not lose events. But what you want to make sure you're not doing is just continually hitting a service. So yes, if you're doing SQS or you're doing asynchronous lambdas, have your dead letter queue, or have now more like destinations. Make sure you get that event, go and throw it somewhere else, stick it in a pile to be looked at later, and just continue moving on. You don't really want to be going into SQS on production and like trying to delete that one message just because it's causing a problem. But a few of us have probably been there. So yeah, it's making sure you again build in a system where you kind of take that event and put it somewhere else, depending on the event bus that you're using.
All right. Well, it's now 5:30, so we've made it to the end of the talks. So some more round of applause for Mark.